In this clip, you will learn to use pandas and NumPy to create some interesting features using existing features of the Titanic dataset. So here we are in our Jupyter notebook. Let's take our age field and use it to create a feature named as age state. So if the age of the passenger is greater than equal to 18, we will treat the passenger as adult, otherwise the passenger will be considered as a child. We are creating this field because it is very much possible that children might have been given priority to be on the lifeboats and in turn have better survival rate. So the age state could be a good indicator of survival. To accomplish this goal, we are using the very handy NumPy where function. So in the where function, we need to supply three things. First is the actual comparison. And here we are comparing age values with the value of 18. So if the condition will be true, then the NumPy where function will return the value of adult. But if the condition is false for certain passengers, then it will return the value of child. We are also storing the result in the age state feature. So this line will create a new categorical feature age state, and it will contain either the value of adult or the value of child depending upon the age of the passenger. Let's execute this line. So now let's quickly see how many adults and children we have in our dataset. Here we are again using the value counts method on the newly created age state column. So we have 1147 adults as opposed to 162 children in the entire Titanic dataset. Now let's also do a crosstab to check the survival rate for different age states. So in the next cell, we are passing the survived column data and age state data for passengers for which we have the survival information. Let's execute this cell. So as expected, survival rate is higher among children because 63 children survived the Titanic disaster as opposed to 54 children who could not make it. So in this clip, we created the age state feature. Now let's create some more features. In this clip, you will learn to use pandas and NumPy to create some more features. Here we are in the Jupyter notebook. Now let's create another feature using the parents and sibling information available in the Titanic dataset. It is very much possible that if there is a small family and one of them got into the lifeboat, then other family members also got into the lifeboats. On the other hand, if the family size is very high, then there could be a sense of panic to select who will go on the lifeboat. Well, let's try to uncover all of these possibilities using a derived feature of family size. So to create the feature of family size, we are simply adding the parent size with sibling size. We are also adding 1 for the self. So let's execute the cell. Now let's quickly see the distribution of family size to have a feel of it. So as you can see, most of the individuals are either single or part of very small family size. However, there is a small bunch on the extreme right with a very large family size. As I told you, extreme values often carry some interesting information. Let's try to explore these extreme values. Here we are extracting rows with family size equal to maximum of family size. Let's execute the cell. So here is the result. Let's extract only few columns. So here you can see there are 11 members in the family traveling on the same ticket, and for 7 of them, we already know that they could not survive the disaster. So it is very much possible that the rest of the 4 who are in the test dataset might also have not survived the unfortunate event. Well, overall, you can see that we are creating a very interesting story here. Now let's quickly create a crosstab on the family size and survived column to see the impact of family size on the survival rate. So let's execute the next cell. So the result shows that for small family size of 2, 3, and 4, more passengers survived. So it could be possible that if one managed to get into the lifeboat, other family members also managed to get into the lifeboat. However, for large family size, the survival rate is very poor. Now let's take ourselves back to the last moments before the Titanic ship sank in the North Atlantic Ocean in 1912. When passengers were put into the lifeboats, mothers with babies could have been given priority over others. So let's check if motherhood has some impact on the survival rate or not. In this clip, we will create another feature for motherhood and check its impact on survival rate. Here we are in the Jupyter Notebook, and we are again using the NumPy where function to create the feature isMother. So what essentially we are saying here is that if a passenger is female and if the P-arch is greater than 0, means they have at least 1 children on the ship, and the age is greater than 18, and the passenger is married, means not having the title of Miss, then we can treat the passenger as a mother and set the isMother property to 1. Otherwise, set it to 0. So let's execute this cell. Now let's again use the cross tab to see if motherhood has impact on survival. And here we can see that 39 mothers survived on the ship as opposed to only 16 who could not make it. So definitely motherhood has some impact on the survival. Now let's see if we can create some more features. In this clip, we'll be working on another feature, that is the deck information for each passenger. Decks can provide useful information about the passenger's location on the ship. It can also give hint towards the socio-economic status of the passenger and availability of lifeboats. Here we are in the Jupyter Notebook. In order to get the deck information, we can leverage the cabin attribute. Let's explore the cabin attribute to get some idea. So here we can see some pattern. We have a letter followed by some numbers. So the letter may be referring to the deck, while the number could be for the room number. You can also see we have so many nans as well. So it could be possible that many passengers were not assigned any particular cabins. Let's use the unique function to get the list of unique cabins. So here you can see we have so many cabins. We have nans as well. And then we have one particular cabin, that is T, that seems to be different from all others. So let's see passengers in the cabin T. So here we are extracting rows for which the cabin value is equal to T. Well, we don't want to create one separate deck for one passenger. So let's assume that the cabin value of T is there by mistake. So we can set it to nan as shown here in the next cell. Here we are setting the cabin to nan if the cabin information is equal to T. Next, let's see the unique cabin list once again. So now we don't have T here. So let's try to find out the deck information, which is the first character. And for all of the nans, we can create a separate deck. Let's name it as deck Z. So in the next cell, we are creating a function to extract the deck from the cabin attribute. Well, don't get scared by this long line of code. Let's break it down. So we are using the NumPy where function and comparing cabin value to null using the pandas not null function. If it is null, then we are returning the value of Z. Otherwise, we are converting the cabin to the string first, then extracting the first character of the string. We are also converting the alphabet to uppercase so that we have all the deck information in uppercase. Then we are using our map function on the cabin attribute and pass the cabin value to get the deck information using the getDeck function. Again, we are using the lambda function trick here. Let's execute this cell. So now we have created the deck feature. Let's see how many passengers we have per deck. Again, we are using our familiar value_counts function on the deck feature. So we have most passengers in the Z category, for which the deck information is not clear. Second most populated deck is deck C. Now let's check the survival rate for different decks using the cross tab. And here we can see that for deck B, D, and E, survival rate is pretty higher. So overall, deck seems to be a very good indicator for survival. Well, so far we have created some interesting features. Now let's use the info command once again to see where we are as of now. So we have 17 features as of now, few of them as integers, couple of them as float, and then we have few features as object and category. So these objects or category are basically categorical features. Categorical features are good for understanding, but unfortunately, most of the machine learning algorithms, which we will discuss in the next module, can work on the numerical values only. They cannot process strings as such. So what can we do about these categorical features? Well, there is a technique to tackle this issue that is known as categorical feature encoding that we will discuss next.